Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 30 on using the Arduino microcontroller. And what we're going to talk about today is we're going to be talking about some advanced software interrupt techniques. And in lesson 28 and 29 we sort of showed you the real simple thing, just the get in and get out of a function to do something like turn something on or off. But sometimes you really do want to do something more sophisticated in a software interrupt, and that's what we're going to talk about today. So what I need you to do is pour yourself a nice big cup of coffee and get ready for some power techniques on using the Arduino. This is actually a real-world problem, and it's a really vexing problem for the Arduino. And let me kind of set up the situation of what we're trying to solve here, and I've got it shown here. Let's say that you want to do something with the GPS. So this is the Adafruit Ultimate GPS, which is made for the Arduino. It's a really great little GPS. It's pretty easy to get it set up. But this is the problem when you really want to go in and start doing something with a sensor like the GPS. And there's a lot of sensors like this. And so I'm just using the GPS as a general demonstration of what the problem is. This is the problem. The GPS just sits and spits out serial data, okay? And it spits it out really fast, just spits it out at 9600 baud for the default baud rate. And it doesn't listen, really, it just talks. So when you power up this GPS, it just starts spitting out data, okay? And what that means is the Arduino, it's not a client-server relationship, it's just the GPS is spitting out data. So what you have to program your Arduino where it's sitting there with its mid up ready to catch the data. Okay, so it's sitting there catching the data. The problem is that the data coming in is very sophisticated. It's a number of different what's called NEMA sentences that have all types of different data embedded in the data stream. And in the Arduino, then you need to go in and you need to start parsing that data. Well, this is the problem. If you go away to parse the data, guess what happens? The data keeps coming in. All right. And so how do you set something up where you go and you catch the data? Because this is the other thing. You catch a NEMA sentence, you go out and you start parsing it, you get the information that you want. Well, what's happened? The GPS has crammed a lot of data into the serial buffer. It's filled it up, it's overflowed the buffer, and so now when you go in to read the buffer, the data is old and it's going to be corrupt because you are going to have more than one NEMA sentence, and that last one is going to be chopped off in the middle, and now you're generating a nightmare of a problem to try to parse it and figure out what's good data, what's bad data. And so to make it even worse, the GPS doesn't just sit and constantly send data. It sends a big burst of data, and then it waits, and then a big burst of data, and it waits. Okay, so this is an example of, to really deal with this, you're going to have to use interrupts. Now, our friends at Adafruit have written like a really nice library because they're like crazy good coders and stuff, and so they wrote a really nice library where you can use this with the GPS. But the problem is, you can use the Arduino with the GPS. The problem is that when you want to go start doing something yourself, those libraries a lot of times don't work because you've got to go in and you've got to start interacting with it. Like imagine that you wanted to not just parse NEMA sentences, collect and parse NEMA sentences from the GPS, but you might also want to be working with a pressure sensor or something like that. So you've got to know how to go in and solve this problem. So what we're going to look at is how to solve this problem. And what I'm going to show you would, while I picked out the GPS to show you, it would really work with any problem where you're having to deal with a sensor that's just spitting out data at you at the Arduino. And so this would work not just for the GPS, but it would work for other software as well. Okay, first step is we need to go in and we need to get a better interrupt library. Okay, in lesson 28 I had you download a simple one, and as we are getting to these more sophisticated techniques, we need a little bit more refined library. And so where I need you to go is, if you go to toptechboy.com, in the link below it'll take you right to this lesson 30, and it will have this link for you. But if you like to do it the old-fashioned way, I am at https://github.com/Paul Stoffregen, that's PAULSTOFFREGEN /timer, capital T, 1 capital O, so timer 1. And then you will get here, and this is a different Paul. There's some great Pauls out there working on the Arduino. But you'll get to this page, then just click on the clone or download. Okay, you can say download zip, and then when you open it, you will see this time 1 master. You need to go to your Arduino folder, okay, which I think is here. Nope. You need to go to your Arduino library folder, which is here. And so you can, I won't step you through it. I stepped you through it in lesson number 28. Basically what you want to do is you want to get the contents of this folder and you want to put it in your library. So you want to get rid of your old timer 1 library and you want to replace it with this timer 1 library. Does that make sense? You take that old timer 1 library, you throw it away, and then you put in this timer 1 library. And I showed you how to load a library in lesson 28, so I'm not going to go through it again other than show you where to get it. Okay, so I have done that, so I now have the new timer 1 library. What we are going to do is we are going to open a fresh Arduino IDE. Okay, and I'm going to show you how to solve this problem. So this is going to be a longer lesson, but I would really appreciate it if you would go through it with me. Okay, so what do we need to do in order to do this? And also, just let me show you that I've actually done it here. If you look at this, I am doing one thing, blinking the LED, while at the same time I'm getting this data that's coming off of the GPS. And this is a very slow blink, so that's a long delay in there. And during that blink, at periodic times, the GPS is spitting data at me, and I have been able to get this to work. So let me step you through this, okay? So let me take a sip of coffee, and let's just jump right in. Okay, there's 2 libraries that you're going to need. You're going to need the include timer1.h, and remember, this is the new one, not the old one. Also, it's probably good after you change that library out if you kill your Arduino IDE and then open it again, just to make sure that you're getting the latest and greatest library that you just installed. Okay, and then we are going to include software serial.h. This software serial is what we're going to use to talk to the GPS. The GPS is sending us serial data, and we will be reading that over software serial. I'm going to download this Okay, I'm going to download this, so you hash include timer1h and then hash include software serial.h. I'm sorry, I was not over here as I was doing this a while ago. Okay, I'm going to download that just to make sure that it works. Okay, to make sure that I've got that library without a problem. Okay, it looks like that was happy. Just with a new library, I'd like to make sure that I can include it. Okay, now I'm going to need some variables. All right, so I'm going to have int flag. The flag is just going to be a useful thing that tells me if I've received a new batch of cereal, so that will make sense later, but it's just to let me know if I have new data. I'm blinking an LED, so I'm going to need red LED, and that is hooked to pin 9. So I set that up. Okay. I'm going to be playing around with a timer in the debugging and so forth. So let's just create a long variable timer. String, I will be reading the NEMA sentence coming from the GPS into a string variable called NEMA, and I'm going to start with that empty, so we will go like that to make sure that we're starting with an empty string. When I read from the GPS, when you're reading over software serial, the old read string function doesn't work, so we've got to read it in one character at a time. So we need a char to read the string into at one character at a time. So we will have a char C, and then we'll build NEMA from the char C's that we're reading in. Okay, normally, you know how I tell you not to cut and paste? Go to the link below in the description of this video and go to the Top Tech Boy Lesson 30, and you have my permission to copy these 2 lines of code because it would be hard to type them in. Okay, and so basically I'm getting a command that I'm going to send to the GPS. Okay, and so what I'm saying is it's a string variable called update 10 microseconds, and then it is this long string. And what the purpose of this is this is a command that I'm going to send the GPS later. And what this is saying is it's telling the GPS to just report every 10 seconds. Because I think in the default condition, it's reporting really fast. And we have enough problems making this work that it helps a little bit if we slow the GPS down. Like, you really don't need data more than every 10 seconds on your location, so we're going to slow it down a little bit. And then the other thing about the GPS in its default configuration, it's sending lots of different types of NEMA strings, and one has one set of data, another has another set of data, and you're getting all of these multiple flavors of NEMA sentences in your data stream. So our life will be easier if we just sort of get the one critical NEMA sentence, which is the GPRMC. And so when I send this command to the GPS in a moment, it will tell the GPS, stop the nonsense, just send me the one NEMA sentence that I actually need. And most of the data is in this particular NEMA sentence. So these are 2 commands that we're going to use later on. Okay, now we are speaking to the GPS over software serial, so I need to do software serial, and I'm going to create an object called GPS serial. Okay, GPS serial, and I'm telling it to go to pin 2 and pin 3. Okay, that's where I'm going to hook the GPS to. And for you folks playing along at home, I will tell you that I have TX of the GPS, TX on the GPS board hooked to pin 2, and RX on the GPS board hooked to pin 3. Okay, and you understand how this works is TX hooks to RX and RX hooks to TX, and so what I just told you will make things work properly if you do the GPS serial 2, 3. Okay, so now I have my object created, software serial, GPS serial 2 and 3. Okay, so that's the stuff that I need to do at the very top. And now I'm going to come down to my void setup, and let's see what we need to do here. Well, we're going to be doing blinking the LEDs, so we better do a pin mode right off the bat. We're going to be doing red LED, okay, and that's going to be an output because we're going to want to blink it. Okay, then I'm going to do GPS serial.begin, and That's 9600. Okay, now you can run the GPS at different baud rates, but when you power it up on the Adafruit GPS, it is running at 9600. So you are going to have to talk to it at 9600. Now, if we wanted to, after we did this serial begin, we could change its baud rate, and then we would have to change the rate at which we're talking about it. So it's really easier just to use the baud rate that its default rate. So we're just going to use GPS serial.begin 9600. We're also going to want to give it a second. So once you start it, it's good to just give it a little bit. So I'm going to put a delay in here. Anytime I'm talking to something like this, a sensor like this, the Arduino is so fast, I want to make sure that it heard the command and had time to think about it before I force another command down its throat. So I'm going to delay. And now I'm going to give it this command. Okay, so it's going to be GPS serial.print. So this print is sending a string command to the GPS. Well, what do I want? I want this one here, so I'll just copy that. GPRMC only, and that is set to this, and so therefore I can just paste that, and now that is sending the command to the GPS. What am I saying? Just send me the one flavor of NEMA sentence. Okay, I want to give it time to absorb that command as well, so I'll give a delay of 100. Okay, and now I am ready to start playing with my interrupts, and so I'm going to start my interrupt. So I'm going to say timer 1 dot attach interrupt, capital I in attach interrupt, and then I'm sorry, I need to initialize it. INITILIZE, initialize, and I'm going to go 1,000 microseconds. Okay, 1,000 microseconds. The units on timer 1 initialize are microseconds, so this is going out every milliseconds. Now, if you think if the GPS is sending data at a 9600 baud, if I operate at 1,000 microseconds or 1 millisecond on the read, that should go out and go get every character. So while I'm doing things up here blinking in the void loop, it's going to be interrupting once a millisecond to go get that next character. Okay, now what do we do? That's setting up an alarm clock that's going to go off every millisecond or 1,000 microseconds. What do I want to do when the alarm clock goes off? I want to attach interrupt. Attach interrupt. Okay, and what do I want to do? I want to read the GPS. Okay, I'm going to read the GPS. Okay, that is my void setup. So I guess the first thing I better do is I better go down and say, what are we going to do in our function read GPS? So I'm going to need to create that. And so that comes after the void loop and after the void loop is closed. Okay, you got to make sure not to put this in the void loop. It's got to be after the void loop closes. So I'm going to say void read GPS. Okay, and then open close on that, and then open curly bracket. What am I going to do? Okay, well, first of all, now understand, did I send that other command? Yeah. So I told up here, I told the GPS, did I send the other command? No, I did not send the other command. What am I thinking? Okay. I skipped something up here. Okay, so I sent it the command of only sending me one sentence, one type of sentence, one type of NEMA sentence. Now I need to do another GPS serial.print. And this time I want to tell it only send me a data point every 10 seconds. Send me a sentence every 10 seconds. So I will come down and I will say update every 10 seconds. Okay, so now I'm going to just get one type of sentence and I'm going to get it every 10 seconds. Believe me, this is a hard enough problem. Don't be a hero. You know, just do this to make it work, because this is actually pretty complicated to get this to work as it is. So I'm going to get one sentence every 10 seconds. Okay, now how often am I going to run out to see if the GPS has anything for me? Well, we already talked about that. I'm going to do that every millisecond. So what you have to understand is you're going to be coming down here to the read GPS thousands of times when there's nothing there. Why? Because when there is something there, you don't want to miss it. You got to think, there's not going to be anything happen for 10 seconds, but then when it happens, bam, 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 you got to read it fast. So if I said, oh, just check it every little bit, the problem is once it starts filling up that buffer, it's going to fill it up and overflow it. So I've got to be checking it every millisecond, and then if there's something there, I will read it in. And if there's not something there, I will want to do nothing, but I've got to check it very frequently. So most of the time when I come down here and check it, you know what? There is not going to be anything there. So I can't just come down here. I can't just come down here and read it, right? I've got to say, I've come down here when the alarm clock goes off, but now I've got to see if there's anything there. If GPS serial dot available, if that's greater than 0, okay, if that's greater than 0, that means there's something there. Okay, if it's greater than 0, that means that there's something there. If not, what's going to happen? If there's nothing there, it's going to jump over this if statement. It's going to go back up to the void loop. So I don't want to just come down here and read. I want to come down here. I want to say, is there any data available? If there is, I'm going to read it. So how would I read it? I would say C. I can only read a char. So remember, C as a char is equal to GPS dot serial. GPS serial. I'm sorry. GPS serial dot read. Okay. Now I have read the character. Okay. Now, why did I put 2 equals there? Were you yelling at me about that? I hope so. Okay. Now, I can just, off that software serial, I can just go grab one character at a time. How do I build the NEMA sentence? I have to concatenate it onto this string. So every character, I've got to grab a character, put it on the string. Grab a character, put it on the string to build my NEMA sentence. So here, what I'm going to do is, after I read the character, then I'm going to say NEMA, the string, concat C. Okay, let me explain. That takes the existing NEMA and it adds to the end of it C. So now the new NEMA is the old NEMA plus C. Does that make sense? I hope so. Okay, so I've now put that on there. All right. Now that ends the if statement. Okay, that ends the if statement. Now, if I just did this, it's going to just keep adding more and more characters until I end up with a NEMA sentence that is 12 miles long. So what I have to understand is that the GPS sends a string of characters, but when it's at the end of the NEMA sentence, it sends a \R. And that's like the period on the sentence. So I've got to be looking for that \R, because that will tell me you got the whole enchilada, you got the whole NEMA sentence. Stop. Don't keep reading. You're done. Okay? So what I need to do then is, after this if statement, I need to see, did I just get to the end of the line? So what I'll do is I'll say if C, if that last char equal, and then one quote \R. Okay, what do I do? That I've got to close that. Okay, What am I doing? Close it. That's got it. Okay. So another if statement. If C, that last char is the \r, that means I now have the whole sentence. So what do I want to do? I want to set a flag. Remember that flag? Flag equal 1. Now what does that do? That tells my main void loop, hey buddy, you got a whole NEMA sentence. Do something with it. Run with it. Okay? Because otherwise it's going to just keep building, 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 building. Okay? Does that make sense? I hope so. So what are we going to do? Every 1 millisecond we're going to jump down into read GPS. The interrupt's going to go off. We're going to jump down to read GPS. It's going to say, hey, is there any data there? If there is, I'm going to read it. If there is and I read it, do I have a whole sentence yet? If no, I'm going to go back and then I'm going to come back and get the next character. Notice that each time in here I only get 1 character. Why? In an interrupt you want to get in and out as quickly as you can. So I'm doing the minimum and then I'm just calling it over and over, building the NEMA sentence, and then when it's done I'll say flag is 1. You've got a NEMA sentence. Hope that makes sense. Alright, so now let's go back up to the void loop. So what do we want to do here? Well, let's go ahead and build the part that deals with the NEMA sentence. So I don't want to do anything with that NEMA sentence because it's going to be put together 1 character at a time. I don't want to jump in the middle of it. I only want to jump in and look at that NEMA sentence if I have a whole sentence. How do I know if I have a whole sentence? Flag equal 1. So what do I do here? If flag equal 1. You know what the most common, right? I teach engineering in high school. I teach Arduino in high school. You know the number 1 mistake that I have that is just a head banging, pull your hair out, try to debug, is you get sloppy, and when you do your conditionals you use 1 equal instead of 2, and then it's really hard to find. And so always look at your conditionals. That's a lot of times where your problem is. Okay, so if flag equal 1, what am I going to do? All right, now this is where you got to be a little tricky, because remember I am out there banging that interrupt every millisecond. I'm out there banging that interrupt every millisecond. And so I've got to be cognizant in my main loop not to be doing something that would mess up with that interrupt. And so you know what I'm going to do, because I'm going to print my NEMA sentence out here? I'm going to stop the interrupt so that it does not interrupt this little piece of code. How do I do that? Timer 1.stop. I'll give you a heads up. This only works if you got that latest interrupt, that original interrupt from lesson 28. It doesn't have this feature. Okay, so I'm going to stop the interrupt. Now also, when I got that NEMA sentence, remember how it had that /r on the end of it? I just want a good old-fashioned string, so I want to take that nonsense off. So I'm going to say NEMA.trim. Okay, and that'll clean any white spaces, any \n, \r's off of it, so you just end up with a cleaner string. Okay, then I'm going to say serial.println. I'm going to print my NEMA sentence. Okay, and then that makes sense. I'm going to print my NEMA sentence. All right, now you got to think, I've got my NEMA sentence, and now I'm going to turn, I'll go ahead and do that now. Okay, timer 1.restart. Now that I've got the slow printing done and I got all this stuff done, it's time to make sure that I'm interrupting again. Okay, got that interrupt going again. So I started it. So I got my NEMA sentence, I printed it. Now what's the problem? I'm going to come out of this and I'm going to start going back looking for the next NEMA sentence. But what do I already have? I already have a long string. What would it do? It would start putting the new one on the end of that string, you know, on the end of the old one. What do I need to do here? I need to reset NEMA to an empty string. That way I'm starting with a fresh sentence. It's like washing your plate. It's like emptying the trash. Okay? And what else do I need to do? Remember, flag was set to 1. And yeah, flag is set to 1 down there. Well, once I've gotten that NEMA sentence, what did I better do with flag? I better set flag equal 0. Okay, I better set flag equals 0. And so you've got to kind of do your bookkeeping so that it'll work fresh the next time like it did the first time. I've got to empty the NEMA sentence and I've got to set the flag to 0. And now what will it do? It will go out and it will start hitting that GPS read again, trying to build the next NEMA sentence. Well, while that's going on, I can do other things. So you would really be doing things like calculation of location or creating a KMZ file. You would be doing really big important things in your void loop. But just to kind of show you the concept, I will do something simple, which we will do a slow blink. Okay, we will do a slow blink on the LED. Now, why are we doing a slow blink on the LED? Because that takes a long time, and that demonstrates that while you're slow blinking the LED in the background with the timer interrupt, it is hitting that GPS read and it is building that NEMA sentence while you are blinking the LED. So let's do this is in the void loop, let's do a little d, digital write red LED, red LED, comma, high. Okay. Delay 1000. Okay, and then digital write red LED low. And then delay 1000. Okay, so you can see if you didn't have the interrupt, this would just work horribly, because while you are delaying, as often as not, in the middle of that delay, the GPS is going to cram a NEMA sentence down your serial port, and then it's going to overflow the serial port because you're sitting here twiddling your thumbs while the data's coming in. Okay, but with the software interrupt, during this delay, it's out there building that next NEMA sentence. Okay, now I'm just curious how many mistakes that I have made that you have found that you are screaming at me over, but we'll likely have to do some real-time troubleshooting. Be patient, be kind. Okay, so let's see what happens if I try to download this. Hey, whoa, huh, bam. Okay, so it actually looks like it downloaded. So let's open up the serial port and see what happens. If I can find the serial port. Okay. Okay, here it is, serial port. I think so. Okay, I'm not getting anything here. Let me close it. Okay, we'll open it again. $115,000. Oh, you know what? I don't think I did. Oh, in my void setup, I did not start the serial port, the old-fashioned serial monitor. Okay, we will do a Did you all see that serial dot begin? How come somebody didn't tell me? Start your serial port. Okay, and 115,200. Guys, man, We have enough timing problems as it is, so if you're going to print something, print as fast as you can, right? So 115,200 will work on most USB cables. So let's download this again. Okay, let's see. All right. Boom! Look at that. Okay, let me explain what that is. I think these first two commands that I got back, that was probably a response that when I did the GPS serial print, it probably sent me a response back. Yeah, I got it. And then when I sent this one, it sent a response back. Then when I went down and started reading, that was like old data that was in the serial buffer. Okay, look at this. Okay, look at this. I am getting NEMA sentences every 10 seconds. Now, I am inside, and so I don't actually have a fix, and so the NEMA sentences are empty. Okay, the NEMA sentences are empty because I am inside, but this would work exactly the same way. When you get a fix, then between the commas, you're getting things like latitude, longitude, elevation, downrange velocity, useful things, elevation, how high are you? So you would be getting lots of interesting things. All right, then what else would you be doing? Well, instead of sitting here just blinking an LED, you would be working with that data and doing calculations and maybe driving a display or creating a KMZ file or doing something else or sending the result to Google Earth. There's all types of useful things that you could be doing when I'm just sitting here blinking the LED. But to show you that this works, look at that. Boom! I've got the LED blinking, and as the LED is leisurely blinking, I am building a NEMA sentence. Okay, I am building a NEMA sentence. So, man, I hope this makes sense, and I hope what you see is that this is kind of where you hit a brick wall with the Arduino, and that is, you know, you get this really slick little thing, and in 10 minutes you've downloaded the Adafruit GPS library, and you just use their library and you put it on there, and it's just spitting out lat long on your screen, and it's great. You think, oh well, this is wonderful, but then when you go and start trying to really do something with it, you find out that you have got to have a technique to be grabbing the data coming from the sensor and then doing something else, and just the standard library that comes with it doesn't do that. And you find this with a lot of these sensors. A lot of these sensors are not client server. They're just spewing, vomiting data at you, and it's all you can do to just catch it. But the problem is, the goal is not just to catch it, it's to do a useful function. To do a useful function, you've got to do the type of thing that I've shown you here. Okay, man, this is really some advanced techniques here, and I'll just end kind of with a caution. You've got to really be careful when you're using these interrupts, because there's a lot of ways that you can mess up. Like imagine up here on my how often I run this interrupt. I've got to make sure, like, you think it only spits data at me every 10 seconds, so I shouldn't be checking it every millisecond. Yeah, but the problem is when it starts spitting data, the amount of data that it spits out is so great that it will overflow your buffer, and when you come around every 10 seconds to read it, you're going to have old or corrupt data. And so you've got to make sure that you don't miss that first character. Therefore, you've got to be hitting it kind of hard, like every milliseconds, okay? And so you've got to sort of really think about how you set these timers up, and it's not for the faint of heart, and it's not for, let's see, I was on the wrong screen, sorry. Okay, it's not for the faint of heart. You know, on setting up your timing, you've got to make sure that you're going fast enough that you're not gonna end up missing it when it comes in. Okay, Paul McWhorter from TopTechBoy.com. Really look forward to hearing your guys' comments below. think about giving us a thumbs up. Thinking about running over and subscribing to the channel? Think about sharing this with other people. Paul McWhorter, TopTechBoy.com. I will talk to you guys later.